Today I want to share my experience from ZEISS Quality Innovations. I was invited there, but I didn't go as a salesman, and this is not a promotional video. I went there as a CMM programmer. I wanted to see what's actually behind the products, how close ZEISS really is to real industry applications, and what this means for people like us who work every day in measurement labs. This video is simply my filtered experience from where I saw, where I learned, and what I think actually matters. Before the actual event started, I spent time at the ZEISS Styli factory in Aalen. This is the place where all Styli sub-assemblies are produced for ZEISS factories worldwide. From what I understood, final Styli are assembled in different locations around the world, but the core processes like milling, laser machining, and the know-how behind how Styli are built comes from here. The glue itself is developed in Oberkochen and then sent both to Aalen and to other factories globally. For Europe, the complete Styli assemblies are also produced here in Aalen. ZEISS explained that they are the only manufacturer using laser technology to machine stylus shafts. Unlike traditional grinding, laser processing creates a polished surface. In daily use, this reduces shaft breakage by more than 50%. Under the microscope, the difference is very clear. Grinding induces surface defects that can become fracture initiation points, while laser machine surfaces significantly reduces this risk. After that, they showed us how CNC machining is used to form the base of the styli, both for the X60 and Vast X60 types. Then we went to the soldering process. ZEISS relies on a vacuum soldering process to connect to the shaft and the ruby ball. This avoids the disadvantages of adhesive connections, such as aging or moisture sensitivity, and significantly increases service life. What stood out to me was how much technological competence is required for this process. Another thing I really appreciated at the Styli factory was the quality control. They use microscopes to check the integrity of the soldering and to remove any unnecessary material excess. They also test the shaft mechanically using gauges to verify that it can withstand the defined force, so they know it won't break in real use. To put things into perspective, the smallest shaft diameter they produce is 0.12 millimeters, and the smallest ruby ball diameter is 0.22 millimeters. Seeing this in real life was honestly impressive. At that scale, everything matters: process controls, precision, and experience. And that was the end of the Styli factory tour. Very technical, very focused, and very grounded. In the evening, starting at around 6 p.m., we went to a rented location in Aalen where everything was set up for the event. There were plenty of seats, food, drinks, and lots of cars on display. Porsche, Ferrari, Ford Mustang, Camaro, Mercedes, and many others, just there to catch the eye and set the atmosphere. For the first hour and a half, the main focus was networking. People from ZEISS were present, introducing themselves, explaining what they do, and making it very clear that they are available if you need them. Business cards, real conversations, no rush. After that, Dr. Mark, member of the executive board from the ZEISS Group responsible for the industrial quality and research segment, held a keynote. He spoke about three major themes: digitalization, decarbonization, and what he called the new globalization era. One idea that stood out to me was that change happens whether we are ready for it or not. Digitalization doesn't wait for permission. Remote work, remote support, and even remote interventions are already possible. On the decarbonization side, he talked about how the push to reduce pollution will gradually reduce the use of combustion engines. His conclusion was that ZEISS stays close to its customers across all three areas. After that, Marek Radke, head of Sales Europe, emphasized again that ZEISS aims to be present and accessible whenever customers need support.
Uniting the invisible with the tangible, science with vision, quality with precision.
Then we had two external speakers, which I personally appreciated a lot. One was Mr. Christoph Pitsch, Senior Vice President at Bosch. He spoke about digital IDs and future possibilities enabled by technology, including things like remote vehicle functions, ownership recognition, control access to assets, and if regulations allows, even remote interventions to our own assets. The second speaker was Bennett Torres from ACC, presenting the only electric car battery factory currently operating in Europe. Despite being on the market for only 5 years, their ambitions and scale were impressive. The event ended with a drone show and more networking. Overall, day one was about people, processes, and context, not products. Day 2 started early in the morning. ZEISS has set up an app that helped with booking presentations and sessions and also coordinated the shuttle buses from the hotels. We left the hotel at 7:55 a.m. and were taken directly to ZEISS site in Oberkochen. At the ZEISS site, several exhibitions areas were set up. There were dedicated stands for ZEISS Inspect, PMI, Service Experience, Calypso, Connected Quality, and PyWeb. Each area had experts available to answer questions and discuss real use cases. Unfortunately, I didn't manage to spend time at the PMI, Service Experience, and Inspect stands. They simply slipped through because the schedule was very tight and I had sessions booked almost every hour. I did have very good discussions, however, with Anna, a project manager from Connected Quality, and with Amadeus, project manager for Calypso. Those were, at least for me, the most interesting areas because they are directly connected to daily CMM programming and quality workflows. There were also a wide range of equipment on display, with ZEISS personnel available to answer questions. One example was the Aramis Adjustable, which provides precise 2D and 3D coordinates for analyzing statically and dynamically stressed components and materials. It's used for applications like tensile tests, bending tests, and compression tests. Another interesting piece of equipment was the Smart Zoom 100 digital microscope. It's designed for optical inspections with a very user-friendly interface. It offers 4K resolution at 60 frames per second and promises a lag-free display. You can also perform simple measurement inspections directly with this microscope. I also got a look at the new ZEISS CMM software for Duramax CMMs, the one some competitors call a replacement for Calypso. Those rumors were clearly denied. This is not a replacement for Calypso. It's a software designed to assist users, especially those with less experience in CMM measurements. That's exactly why it's running on a Duramax. The software automatically defines the navigation strategy and stylus assignment strategy. From a user interface perspective, it resembles ZEISS Inspect quite a lot, since it's built on the same platform. But probably the most interesting conversation I had that day was with Dr. Robert Rothmeyer. He is the author of several metrology books and is deeply involved in knowledge management and outcome trainings. I asked him a very simple question: what is, in your opinion, the most complicated part of metrology that engineers struggle with today? His answer surprised me a bit because it made a lot of sense. His answer was Fourier analysis. He explained that through different types of filtering, we can evaluate measurements much more accurately. We can better understand where certain deviations are coming from, whether they are form-related, process-related, or noise. In that sense, Fourier analysis helps bring measurements to the next level of precision. It was a very interesting perspective, especially because it's a topic that many engineers tend to avoid or underestimate. After that, I joined the presentation by Philip Walter, Managing Director at Liebherr. They presented their key product areas, from construction and mining machinery to refrigerations and freezing equipment, cranes, and aviation components. What I appreciated was that the focus was not on the products, but on the challenges. They spoke openly about regulatory pressure and bureaucracy, technological challenges and innovation, and the coexistence of old and new equipment, especially in aviation. I also joined the innovation tour. Not on the standard path. Thanks to my friends from eMacro, I had the chance to see different parts of the building. Unfortunately, I can't really talk about that part, but I can say it was eye-opening. I arrived at the X-ray and CT presentations. Here I learned how AI is already being used to detect different types of defects. Defects such as dents, insufficient materials, and internal cracks. What I found particularly interesting is that the AI can be trained. You can teach it to recognize defects that are specific to your own parts. The need for AI comes from how CT data is evaluated. CT works with grayscale values, and based on those values, defects can sometimes be falsely detected, or relevant defects can be missed. With proper training, the AI can learn what should be ignored and what should be highlighted, and then point those areas directly to the user. Since I don't work with CT systems myself, Ekaterina Schuster, one of the people responsible for the CTs, explained something very clearly to me. She told me to think of a voxel as a 3D pixel. That's essentially what a CT scan returns, a 3D grid of voxels. She also explained the new device used inside the CT called the horizontal field of view extension. This allows scanning parts that are significantly wider than the detector, or alternatively, scanning smaller parts with smaller voxel sizes, which returns in much higher resolution. That part was truly fascinating. Then I saw an Audetect measuring a glass syringe, and I was curious, how was that possible? Apparently, it uses the dot scan, a chromatic white light sensor that enables non-contact measurements of workpieces. These sensors are especially useful when dealing with sensitive or reflective or low contrast surfaces where other optical sensors might struggle. In this case, it was used to measure the thickness of the syringe walls and the diameter of the cylinder. What I also found interesting is that Auditech combines optical and tactile measurements since it has a built-in measuring head. I also saw an automatic inspection setup using a robotic arm and a microscope. Several parts were placed on a tray, the robot picked them one by one, positioned them under the microscope and performed the inspection, and then replaced them with the next part. Efficient, reliable, and without human error. They also showed me different types of microscopes used for technical cleanliness inspections. Here as well, AI is now integrated into the interpretation process. It can learn to identify defects and interpret what is visible under the microscope. It became very clear that ZEISS is using different deep learning techniques across multiple types of equipment. One detail that caught my attention was a stylus holder rack that moves and rotates. It allows easy access to any stylus directly on the CMM. A small thing, but very practical. Later, I attended another presentation called Transition from 3D Master to MBD and MBA. Andreas Berwind from Scheffler presented how they are using 3D PDFs with model-based definition as technical data, instead of traditional technical drawings. The PDF was fully interactive, you could rotate the part, view different sides, sections, details, and access all the required technical information directly. It was a next-level technical data representation. After that, I visited the ZEISS Museum. There, I saw different types of microscopes from various eras, cameras from different generations, glasses, and old telescopes. It was a short visit, but it really put things into perspective. How long ZEISS has been building optical and measurement knowledge. At the museum, I had the chance to ask Mr. Dan, CEO of Macro, the one who invited me to this event, a few questions. So I'm here at the ZEISS event and I don't want to miss the opportunity to ask Mr. Dan from Macro, the representative of ZEISS from Romania, some questions. So we will have to see exactly what he has to say about the event and about what happens here at ZEISS. Domnule Dan, cum vi se pare evenimentul din interior ca om care lucrează zi de zi cu astfel de echipamente?
Evenimentul a fost optimist, ceea ce m-a bucurat foarte mult și îmi doresc ca și următoarele evenimente de anul acesta să fie la fel.
Super.
Sau cel puțin la fel.
Super. Și care a fost discuția sau prezentarea care vi-a atras atenția cel mai mult, care vi-a plăcut cel mai mult?
Cel mai mult mi-a plăcut prezentarea delegatului de la Bosch.
Ok.
A fost antrenantă, a fost plină de noutăți și a fost la obiect.
Da, așa este. Așa este. Și mie mi-a plăcut foarte mult. Perfect. Legat de echipamentele care s-au prezentat astăzi aici, care credeți că dintre ele ar putea ajunge cel mai repede la beneficiarii care chiar au nevoie de ele?
După părerea mea, accesoriile legate de automatizare.
Ok.
Da? Trendul în industrie este pentru automatizare. Se pot automatiza acum foarte bine și mașinile de măsurat și tomografele industriale. Se pot industrializa și automatiza foarte bine măsurătorile în general.
Așa este, așa este. Ăsta este trendul și sper și eu ca toată lumea să meargă în direcția asta.
Da.
Super. Și o ultimă întrebare. De ce credeți că specialiști ca și mine ar trebui să participe la astfel de evenimente?
În ziua de astăzi, networking-ul este foarte important. Odată ce participați la asemenea evenimente, cunoașteți specialiștii din alte țări, de la alte fabrici, din alte domenii, faceți schimburi de informații, așa cum ați putut să faceți și astăzi, ceea ce este foarte important și ceea ce va aduce un beneficiu și firmelor la care lucrați.
Super, Vă mulțumesc frumos
Mulțumesc
și
și
vă
eu.
doresc distracție plăcută în continuare.
Mulțumesc!
And there was still enough time to return to Amadeus and ask him some very specific questions about Calypso. I described the real problem I had in practice. A part with an irregular contour, heavily deformed, where I had difficulties properly capturing the surface. He suggested using a cylindrical stylus and explained the difference between the VASTIC 60 head and the RDS CAA head. He explained that the VAST head touches the contour with a constant measuring force. The RDS head tries to do the same, but because it is built differently, it cannot maintain the same behavior on complex contours. Then we discussed another very specific issue. I had a feature where I was using formulas to capture points on a deformed surface. Even though the features were ordered correctly and the run order was set properly, the CMM kept changing the stylus after each hit. This expanded the program runtime significantly. We agreed that this behavior looked like a bug and was worth investigating further. We also talked about the plane used in the base alignment. It was built using different styli and different angles, and it was built using recall from different surfaces. Because of this, the machine kept changing the stylus system repeatedly, which again increases the runtime. During this discussion, I realized that the plane itself was actually created by recalling points from several planes, so I could completely change the strategy and build a single plane instead. That alone eliminated unnecessary stylus changes and saved a lot of time. This is exactly why it's so valuable to talk to people who really know the job. Sometimes it's not about adding complexity, but about stepping back and changing the strategy. We also talked about the new default datum evaluation method according to ISO 5459, specifically how the datum plane is now evaluated as a Gaussian plane, filtered and then shifted to a Gaussian outer tangent. It was good to see that Calypso 2025 already supports this evaluation for planes. We spent almost an hour together. I was honestly mesmerized. After that, the event officially ended, and we were invited to the canteen for the evening after party. I had the opportunity to sit close to Dr. Robert Rothmeyer again, and of course, we continued the discussion. This time, we talked also about the ISO 5459. Dr. Robert also mentioned the morphological filter that should be applied in relation to the Gaussian plane. We talked about the path a measurement engineer usually follows, outcome trainings, measurement software trainings, and the importance of continuous learning. We also discussed how he tried to resolve issues related to the default evaluation method using the ZEISS cookbook. That's why we have Gaussian evaluation for process controls and ISO or ASME related defaults for functional checks inside the cookbook from ZEISS. All I can say is that the evening became even more interesting than expected, and that I'm truly grateful for the opportunity to sit down and have the discussions with Dr. Robert. After these 2 days, I understand much better how big ZEISS really is. Not just as a company, but in terms of the range of products and industries they actually impact. What stood out to me the most is how focused they are on real applications, on what users actually need, and on what the market is asking for. ZEISS is truly a complete inspection-based supplier with a very strong focus on automotive, aerospace, and medical applications. I also gained some very concrete insights that really put things into perspective. For example, the lids of the pasteurized baby foods are inspected using ZEISS microscopes for quality checks. or the coffee grounds inside a coffee capsule are inspected with CT scanners to verify the quality and the quantity and to make sure the quality is not affected. These are small things we don't usually think about, but they show the real impact ZEISS has around the world. For CMM programmers, I think there are a few important takeaways. First of all, Calypso is going nowhere. ZEISS is clearly investing in it and doing their best to stay close to the people who actually use it every day. Have the courage to ask questions on the ZEISS forum, use the My Voice system to propose new options or improvements, and don't skip opportunities like this kind of event. They give you the chance to learn a lot, not just about the software, but about the bigger picture. Also, keep an eye on automation and AI. This will not take your job away, but you do need to be prepared for it. You need to understand how this system works and how to operate it. So keep learning. Overall, the event helped me better understand the impact ZEISS has worldwide, and I am grateful I had the opportunity to experience it from the inside. This was my experience, not a promotion exactly like I stated from the start, just what I saw as a CMM programmer. Until next time, learn as much as you can from wherever context you can.
Ich häng an deinem Lippen, du schön und schlau, studierter Bock.